Assalamualaikum. Today, I will present our group project introduction and methodology of our study. Our study used the new car sales in Norway dataset from Kaggle. This dataset contains monthly record of new passenger car sales in Norway from 2007 to 2017. It includes information such as the year, month, car manufacturer, sales quantity, and market share. The purpose of this study is to analyze the monthly sales performance of 5 major car manufacturers: Audi, BMW, Lexus, Mercedes-Benz, and Volkswagen. We also compare the sales between June and December to see whether there are significant differences. For the methodology, dataset explanation. For our methodology, we use the new car sales in Norway dataset for Kaggle. The original dataset contains 4,277 observations collected from 2007 until 2017. The variables include year, month, car manufacturer, sales quantity, and market share. For this study, we focus only on 5 manufacturers: Audi, BMW, Lexus, Mercedes-Benz, and Volkswagen. We also selected data for June and December to analyze the seasonal difference in monthly sales. Next, method of analysis. To achieve our objective, we use 3 statistical methods. First, descriptive statistics were used to describe the characteristics of the data such as frequency, mean, standard deviation, minimum and maximum values together with charts. Second, one-way ANOVA and the 2K STA406 test were used to compare the mean monthly sales among the 5 car manufacturers. Finally, the independent sample t-test was used to compare the mean monthly sales between June and December. Lastly, software use. For data analysis, we use IBM SPSS statistics. SPSS helps us calculate the descriptive statistics, perform the one-way ANOVA, conduct the 2K STA406 test, and run the independent sample t-test. It also makes it easier to manage the data and interpret the result accurately. That's all for my presentation. I will now pass the presentation to the next presenter.
I will be presenting our research findings regarding the Norwegian automotive market. Let's start with Objective 1, which is to describe the characteristics of vehicles and evaluate their overall sales performance in Norway. To get a clear picture, we choose descriptive statistics as our primary method. This involves looking at key figures like frequency distributions, means, standard deviations, minimums, and maximum values. For this analysis, our variables are separated into 2 distinct groups. First, we have vehicle characteristics, serving as our categorical or nominal variables, capturing qualitative attributes like the car manufacturer, model, and vehicle category. Second, we track quantitative sales performance metrics using continuous ratio variables, which include the total number of cars sold, market share, and time frames. This method is highly appropriate because it allows us to simplify a large complex automotive dataset into clean, meaningful summaries without altering any of the primary data. Now, I will explain Objective 1, which focuses on the frequency distribution of respondents based on their preferred car manufacturer. First, let's look at the total sample size shown at the bottom left of the slide. There were 606 valid responses collected, giving us a 100% valid response rate. This means that every questionnaire received was complete and usable for the analysis. Looking at the frequency distribution table, we can see that the respondents are distributed almost equally among the 5 car manufacturers. 4 of the manufacturers, which are Audi, BMW, Mercedes-Benz, and Volkswagen, each have 121 respondents, representing 20% of the sample. Lexus have 122 respondents, which is 20.1%, making it the highest by only one respondent. The bar chart in the center clearly illustrates this distribution. All the bars are nearly the same height, showing that each car manufacturer has almost the same number of respondents. Next, looking at the descriptive statistics under the report section, we can draw several clear conclusions about the number of cars sold across the 5 car manufacturers. As we can see, the market leader, which is Volkswagen, is the clear outlier on the high end. It has the highest average sales by far, with a mean of 1,708.1 units. It also records the single highest sale peak in the entire dataset, with maximum of 3,017 units. On the other hand, the mid-tier performers, which is BMW, Audi and Mercedes-Benz. BMW leads this group with a mean of 605.91 units, but it shows high volatility, which is standard deviation of 247.42, indicating some exceptionally good periods, maximum of 1,663. Audi follows closely with a mean of 582.44 units. Audi's sales are relatively stable compared to BMW, with a much lower standard deviation, which is 115.60 units. Mercedes-Benz trails slightly behind them with a mean of 475.168 units. Lastly, the lagging performer, which is Lexus, performs significantly lower than all other brands in this dataset. It has an average of just 44.13 units sold, and even its absolute best performance, which is maximum of 147, does not reach the minimum sales floor of any other brand.
Next, I will present Objective 2 of our study. The objective is to determine whether the mean monthly sales differ among 5 major car manufacturers, namely Mercedes-Benz, BMW, Audi, Lexus and Volkswagen in Norway from 2007 until 2017. To achieve this objective, we use one-way ANOVA followed by the Turkey HSD post-hoc test. One-way ANOVA determines whether there is an overall significant difference among the 5 manufacturers, while Turkey HSD identifies which specific manufacturers differ significantly. Before performing the one-way ANOVA, we first check the assumption of homogeneity of variances using Levin test. The null hypothesis states that the variances of monthly sales are equal across all 5 manufacturers, while the alternative hypothesis states that the variances are not equal. Based on the output, the p-value is greater than 0.05. Therefore, we fail to reject the null hypothesis, indicating that the assumption of equal variances is satisfied. Since this assumption is met, we can proceed with the one-way ANOVA. Next, this slide presents the result of the one-way ANOVA. The null hypothesis states that there is no significant difference in mean monthly sales among the 5 manufacturers, whereas the alternative hypothesis states that at least one manufacturer has a different mean monthly sales. From the ANOVA table, the p-value is less than 0.05. Therefore, we reject the null hypothesis and conclude that there is a significant difference in mean monthly sales among the 5 manufacturers. However, ANOVA doesn't identify which manufacturers differ. Therefore, we proceed with the Turkey HSD post-hoc test. After obtaining a significant ANOVA result, we conducted the Turkey HSD post-hoc test. This test compares every pair of manufacturers to identify where the significant differences exist. The result shows that almost all manufacturer pairs have significant differences in their mean monthly sales. However, Audi and BMW are the only pair with no significant difference, as their p-value is greater than 0.05. This indicates that the average monthly sales of Audi and BMW are statistically similar, while the other manufacturers differ significantly from one another. Based on the overall analysis, we conclude that the mean monthly sales differ significantly among the 5 major car manufacturers. Among the manufacturers, Volkswagen recorded the highest average monthly sales, while Lexus recorded the lowest. In addition, the TQHSD analysis shows that Audi and BMW have similar average monthly sales, whereas all other manufacturer pairs show significant differences. Overall, these findings suggest that consumers' preferences and market performance vary across manufacturers in the Norwegian market during the study period.
Our third objective is to determine whether the mean monthly sale differs significantly between June and December in Norway from 2007 until 2017. To achieve this objective, we use an independent sample t-test. This statistical method is suitable because our study compares the average monthly sales quantity, which is continuous variable, between two independent groups, which are June and December. It is the most appropriate statistical method for this objective. Next, before interpreting the t-test result, we first need to check one of the assumptions, which is the homogeneity of variances using Levin test. There are 5 steps. Step 1, to state the hypothesis. H null, variance 1 equal to variance 2. H1, variance 1 not equal to variance 2. Step 2, the significant level. Alpha equal to 0.05. Step 3, test the hypothesis. P-value is 0.674. Step 4, p-value 0.674 is more than alpha 0.05. Therefore, fail to reject H null. Step 5 is the decision. Since p-value 0.675 is greater than alpha 0.05, we fail to reject the H null hypothesis. This means the assumption of equal variance is assumed. Now, let's look at the independent sample t-test result. There are 5 steps. Step 1, state the hypothesis. H null, mu June equal to mu December. For H1, mu June not equal to mu December. And here is our claim. Step 2 is critical value, where alpha equal to 0.05. Step 3, test the hypothesis, where p-value for two-tail is 0.740. Step 4, make the decision. Since p-value 0.740 is greater than alpha 0.05, we fail to reject the H null. Step 5, make the conclusion. This indicates that there is no statistically significant difference in the mean monthly sale between June and December. Overall, this study successfully achieved all 3 research objectives by applying appropriate statistical method using IBM SPSS. For Objective 1, descriptive statistics provide a clear overview of the characteristics of the selected car manufacturers and their monthly sale performance in Norway. For Objective 2, the one-way ANOVA analysis shows that there is a statistically significant difference in the mean monthly sale among Audi, BMW, Lexus, Mercedes-Benz, and Volkswagen with a p-value less than 0.001. This indicates that the car manufacturer has a significant influence on the monthly sale performance. And for Objective 3, the independent sample t-test show no statistically significant difference in the mean monthly sale between June and December. This means that the month itself does not significantly affect monthly vehicle sales between these 2 periods. Overall, the findings demonstrate that the type of car manufacturer has a greater influence on vehicle sales than the difference between June and December. These results provide useful insight for understanding sales performance and support data-driven decision-making in the automation industry. Based on these findings, we propose several recommendations. First, automobile manufacturers should continue improving their marketing strategies by offering more effective promotions and strengthening their market positioning to increase sales and remain competitive. Second, companies should adopt data-driven decision-making by regularly analyzing sales data. This can help identify market trends, improve forecasting accuracy, and support better production and inventory planning. Third, manufacturers with strong sales performance should continue maintaining their successful business strategies to sustain customer satisfaction and market share. Finally, future research should also include additional variables such as vehicle price, fuel types, economic conditions, and government incentive. Researchers may also apply more advanced statistical techniques such as multiple regression or time series analysis to gain a deeper understanding of the factors influencing vehicle sales. Thank you. That concludes our presentation. We appreciate your attention and welcome any questions.